Hello students, this is Swapnil Dage. Welcome to the Maths Magnet. Today we are going to start with the new chapter which is number system. So this chapter is going to be useful for the standard 8, standard 9 and standard 10. So these are the basic topics which are required for understanding the basic mathematics. So that we can understand we can better understand about the mathematics. So let us start with the number system. In that we have one first chapter is rational numbers. Till now, till the standard 7, we already knew about the natural numbers, right? Natural numbers. So in the previous classes, we have already learned about the natural numbers. So what are the natural numbers? The natural number means what? The numbers which are starts from 1 means the numbers which are required for counting the objects, counting the objects. That all numbers are known as natural numbers, which starts from 1, 2, 3, 4 up to positive infinity. It tends to infinity, right? And when we include 0 before 1, all natural numbers together with the 0, all natural number together with the 0, that numbers becomes whole numbers, right? And we also knew about the integers. So whole numbers including negative of natural numbers are called integers. Means when we write the natural numbers, we start with 1, 2, 3, 4 up to that will be goes up to infinity or positive infinity, we can say. Whole numbers means 0, 1, 2, 3 up to infinity, right? And the integers are the numbers which are including the negative numbers also. When we write 0, when we start with the 0, 1, 2, 3, positive infinity, and when we add or when we include the negative numbers also till negative infinity, this the set of numbers are comes under the integers. And what we are going to study about the number system, in the number system, that is a natural that is rational numbers. So rational numbers can be written in form of p by q. The numbers which are written in the form of p by q. P by q means here p is numerator and q is denominator. P is numerator and d is denominator. Q is denominator here. So remember one thing here, the p and q, the p and this q must be or can be integers. Okay, this is very important to remember here, that this p and q are integers. But important in this is q never be equal with the 0. When we write the rational numbers, and when we suppose we have this minus 2 by 0, so this we cannot write this q or denominator of the fraction or the rational number as 0. When we write that 0, that numbers tends to infinity, means we cannot divide this minus 2 by the 0, right? So remember here that this p and q, will be integers, means that may be positive number, that may be negative numbers, but this q should not be equal to 0. Okay, so this is about basic concept about the rational numbers. So when we uh, draw the diagrams, or we can say that when we draw the when we uh, understand regarding the natural numbers by using the diagrammatic form. So these are the natural numbers. When we write or when we include 0 in that, that becomes whole numbers, these 0, 1, 2, 3. When we write the negative numbers also, minus 1, minus 2, minus 3, that, and 0, 1, 2, 3 positive numbers also, that becomes integer. And when we have this numerator and denominator numbers, means the numbers which can be written in the form of p by q, or fraction, we can say that fraction, and this fraction we can write this fraction in decimal point form. Okay, so minus 4 by 5, these are some examples. 3 by 7, 8 by 9, or we can write minus 2 by 3. So these type of numbers are comes under this rational numbers. So let us understand the better understand about the rational numbers by taking some examples. So we have, suppose we have this equation here, x plus 8, x plus 8 is equal to 15. This is the equation. When we solve this equation, actually what is the solution of the equation means we have to find the value of the x here. So when we solve this, x is equal to 15 minus 8 will be 7. So we got here the 7. The type of number we got is natural number, right? We have this positive 7, and positive 7 is natural number. Z plus 11 is equal to 11. When we solve this, z is equal to 11 minus 11. This will be 0, and 0 is whole number, right? When we solve again, x is equal to 2 minus 15, we got minus 13 here. So minus 13 is a integer. Let us solve another example. 3x is equal to 2. 3x is equal to 2. So x will be 2 by 3, because this 3 in the left hand side, this 3 is multiplied by this x. So when we take that 3 to the right hand side, this this will be divided by this 2. So when we divide this 3 by 2, it becomes x is equal to 2 by 3. So 2 by 3 means this number is in the form of p by q, and we have already seen here that the numbers which can be written in the form of p by q, that numbers are known as rational numbers. So we got here 2 by 3, this is a rational number. So we have another example here that 7x plus 4 is equal to 0. So when we solve this, x is equal to minus 4 by 7. So we got here minus 4 by 7. How come we got this minus 4 here? When we take this positive 4 to the right hand side, this becomes minus 4, and when we take this 7 to the right hand side, this 7 is multiplied by this x here, and when we put when we take that 7 to the right hand side, that becomes the denominator of this minus 4. So we got minus 4 by 7. So we got here minus 4 by 7. You can put this negative sign to the numerator also. You can put this negative sign in the middle of two numbers also, and you can write this sign as the denominator or minus 7 also. So these all the numbers are same here. Minus 4 by 7 is also equal with this minus 4 by 7 is also equal with this 4 by minus 7. So these two examples are about the rational numbers. So we got the rational numbers here. Now we have solved this. So from this above examples, we got natural numbers. Here we got natural number, here we got whole number, here we got the integer, and in the both the second last and last example, we got the rational numbers, right? We got here after solution, we got rational number here. Now in this we will explore properties of the rational number. So in this chapter we are going to study more about the properties of the rational numbers, representation of the rational numbers in the number line or on the number line. We already seen how to show the positive numbers, mean natural numbers on the number line, whole numbers on the number line. Similarly, we already knew about the how to show the integers on the number line, and now we are moving towards the how to show the rational numbers, two rational numbers on the number line, or the numbers, two rational numbers, relation between the two rational numbers or comparison of the rational numbers. So let us move ahead. So we will have here rational numbers. So let us learn more about the rational numbers. It is very important topic while studying the mathematics. The main or important topic in that is number system, and under the number system we are having this rational number. Okay, so rational numbers. So main properties of the rational number, as we have seen earlier, that any numbers which can be written in the form of p by q, where p and q are integers, and important parameter in this is q should not equal to the 0. So these type of numbers are known as rational numbers. We have note here, if a whole is divided into equal parts, then each part is called a fraction of the whole. Let us understand this with one example. If the whole is taken as 1, the whole number means not whole number means not here 0 1 2 3, that is not whole numbers here. So we are going to take one example here. So for example, 1 by 10, 1 by 10, 1 by 5, 1 by 8 are fraction of 1. These numbers are fraction of 1, fraction of 1. 1, we have considered 1 as a whole number, 1 as a whole number, and these 1 by 10, 1 by 2, 1 by 3, 1 by 4, 1 by till 1 by 9, these numbers are fraction of the 1. Okay, so uh, we have another important topics, we have another important properties of the rational numbers. So let us understand some properties of the rational numbers. So these are the very important properties. Let us learn about these properties here. First property in that is all integers are also rational numbers. So we have already studied that -3, -2, -1, 0, 1, 2, 3 up to infinity, and this is up to minus infinity. So all these numbers are integers. Are you getting? All these numbers are integers, but these all numbers are comes under rational numbers also, because what we have studied in the definition of the rational number, that the rational numbers are in the form of p by q, and that q should not be equal to 0. So in this case, we have by default denominator is 1. By default denominator 1. All the numbers having the denominator as a 1. So in this case, this is numerator, this is denominator, numerator, denominator. So all the numbers are in the form of p by q. All the numbers are in the form of p by q. So we got here the numbers which are in the form of rational numbers. So we can write, or we can conclude that here, that the all integers are rational numbers. So this is the first and important property of the rational numbers, that all the integers are rational numbers. Let us learn about the second property. If the term has negative integer in its denominator, like this, -3, 2 by -3, a term has a negative integer in its denominator, the negative sign of the denominator is shifted to the numerator. We can shift this negative sign. This number can be written like this also, -2 by 3. Earlier we have this number 2 by -3, but we can write this number as -2 by 3. Okay, this is the property of the rational number. We have another property here. If p and q are two co-prime numbers means what? Numerator and denominator have no common factors other than 1. Means let us take this example, 2 by 3. So 2 by 3 are the co-prime numbers. Why? Because the factors of 2 is 1 and 2, factor of 3 is 1 and 3. So these two numbers, 2 and 3, these numbers do not have any other common factor except this one. Are you getting? So these are the co-prime numbers. So then the rational number is said to be the lowest form. Usually we write a rational number in its lowest form or simplest form after cancellation of the common factor from the numerator and denominator. Let us understand this property by taking one example. So we have this 2 by 3 as a lowest or simplest form, we can say that. So we have this, suppose we have this 8 by 12 here. So let us simplify this 8 by 12. So 4 2s are 4 3s are. We have got this 2 by 3 here. So 2 by 3, it is the simplest form of this 8 by 12. Simplest form of the 8 by 12. So we got this number here 2 by 3. Similarly, when we have suppose minus 16 by 20, when we simplify or when we take the lowest form of this will become 4 by 5. 4 4s and 4 5s are 20. So we got this -4 by 5. This is also the we got this number -4 by 5. So these are the this is the important property that what is the property? What is the property here actually? If p and q are the two co-prime numbers, if p and q are two co-prime numbers, that then the rational number is said to be in the lowest form. This is actual property. Next property is there are infinite rational numbers equivalent to the given rational number. For example, rational numbers equivalent to 2 by 3. 2 by 3, we can write infinite equivalent number. Suppose we have 2 by 2, we have these two numbers here, we have one rational number here 2 by 3, so we can write this 2 by 3. When we multiply this 2 by 3 by 2 by 2, we will having 4 by 6. When we multiply this with the 3, so first number we got this 4 by 6 here, then we got 6 by 9 here. Okay, when we multiply this number by 4, we will having 8 by 12 here, so we got 8 by 12. So we will have the infinite equivalent numbers. 4 by 6, 6 by 9, 8 by 12, we will having infinite equivalent numbers. There are infinite rational numbers equivalent to the given rational numbers. And we have another property that there are infinite rational numbers between two rational numbers. Okay, suppose we have these two numbers 1 by 2 and 3 by 4. So we will having more than, not more than, we are having infinite numbers between these two rational numbers. Okay, so let us solve about let us understand the next property about the rational number. So we got here rational numbers with its numerator greater than. Suppose we have this example here 22 by 7. So numerator in this case is greater than the denominator. The denominator can be written in the mixed form. For example, we have this minus 22 by 7. We can write this rational number in the mixed form. But when we can write such rational number in the mixed form, that the condition is that the denominator must be less than the numerator. Denominator must be less than the numerator. So we got minus 22 by 7. We can write this, when we divide this 7 3s are 21 and we got 1 here, so we can write this minus 22 by 7 like this. So 7 as it is minus, this will be, this is minus 3, and we have to write this remainder to the numerator here. So we have written this minus 22 by 7 in the mixed fraction. This is simple fraction, okay, and this is mixed fraction. This is another property. And last property will be rational numbers can also be written in the decimal form. We can write this 5 by 2 like 2 by 5 here, 2.5, right? 5 by 2, 5 by 2. When we divide this 5 by 2, we will having this 2.5 here. So we can write this fraction as a decimal form, or we can write the rational number in form of the decimal form. Okay, so these are the important properties of the rational number. So let us understand more about the rational numbers. In that, we have next topic, that comparison of the rational numbers. So let us compare the rational numbers. Compare means which number is greater, which number is smaller, or larger number, smaller number, or equal numbers. So let us understand how to solve such kind of questions in this topic. So first we have to find the LCM of the denominator. Suppose we have these numbers 3 by 5, 2 by 7 and 2 by 3. So we have these three rational numbers with us, and I want to find which number is greater, which number is lesser. Okay, so how to find that? So I'm going to find the LCM of these denominator values. So 5, 7 and 3. So the LCM of these 3, 7 and 5 is 105. So these numbers, when we multiply these numbers by a constant number, we are having the number 63 by 105, 30 by 105, 70 by 105. So we got the denominator equal here. So we have made all the denominators same, and after making same denominator, then we can judge which number is greater, which number is smaller. So we got 30, 63 and 70. So 30 is less than 63 is less than 70. So greater number is 70. So we can write here that 70 by 105 is greater than 63 by 105 is less than 30 by 105. So we can write in this form also, 2 by 7 is less than 3 by 5 is less than 2 by 3. So in this example we have to do the denominator equal, or we have to find the LCM of the denominator and let us equal the denominator, and then we can compare the rational numbers with each other. So example, we have one example here. They have given us to find the lowest form. Okay, so we are going to study about the rational numbers, comparison of rational numbers. So before studying the comparison of rational numbers, we have to understand how to take this or how to find the lowest form of the rational number. So we have this 54 by 75. 54 by 75. So how to solve that? We have to find such a number that numerator and denominator, both the numbers should be divided by same number. So when we think we will having when we divide this numerator and denominator, both the numbers should be divided by same number. So we got here 3. So when we divide this 54 by 3, we will having 18, and when we divide this 75 with the 3, we will getting 18 by 25. So we got 18 by 25 when we dividing both numerator and denominator by 3. So we cannot further simplify these numbers. We cannot further simplify 18 by 25. So we got the lowest form or simplest form of this such rational number here. So we got the solution here, 18 by 25. So you have to, after division or after simplifying, you have to check whether these two numbers are divisible by same number or not. If the division is not possible further, so you have to stop there. So this will be the lowest form or simplest form of the rational number. Okay, so let us divide, or let us solve the next numerical. So we got here minus 100 by 49 is in its mixed form. Minus, we have to do the mixed form of the fraction. Okay, so how to find the mixed form? So let us divide this 100 by 49. So 49 twos are how much? 49 twos are will be 96. Right? 49 twos are 98. 49 twos are is 98. So we got 2 here. Okay. So we have 49 as a denominator. 49. So we have here that 49 as a denominator, and write this quotient here. 49 twos are 98. 49 twos are 98 plus this 2 plus this 2. So we got, and we have this negative number with the 49 here, or you can write here also. So we got here minus 2. Okay, minus 2 and 2 by 49. So this is the division method. By using division method, we have written this in the mixed form, right? And we have already the mixed form in the third example, 2 3 by 10. Okay, so we have to write this in the standard form. Okay, so how to write that? Let us understand. So 2 3 by 10. So multiply this 2 into 10 plus 3 and write this denominator as it is. So we will having 2 into 10 is 20 plus 3 by 10, and we got 23 by 10 here. So we got the 23 by 10. 23 by 10, which is we have solved, or we have bring that 2 3 by 10 into the standard form, which is 23 by 10 here. So we have solved the examples, and what we have learned in that is how to compare the two rational numbers or three rational numbers, how to compare the two or three rational numbers, how to compare that. When we want to compare the rational numbers, we have to make the equal denominator first by finding the LCM of the denominator. When we have equal denominators, we can easily compare the numerators of the rational numbers, and we can find the comparison easily. When we want to find the lowest form, we have to divide numerator and denominator with the common number till the we will find the simplest form or lowest form. We have converted the standard form into the mixed form also, and we have already converted the mixed form into the standard form. So let us understand further about the rational numbers in the next lecture. Thank you.